whenever I made the Bible video, I had a great idea someone said about reading my textbook, and I don't have a physical one, unfortunately, so I am just going to read off my textbook from my online textbook. So let me go right here real quick. A little farther out than I thought it was. Okay. So I'm just going to start up on the muscles because that's what we're on right now, is the muscular system. So, brushing up. Understanding of the skeletal muscles depends on a thorough knowledge of the skeletal anatomy, including not just the bones but also their surface features, many of which are muscle attachments. This chapter describes the movements produced by muscles, called their actions, using terminology of joint movements. Muscles constitute nearly half of the body's weight and occupy a place of central interest in several fields of healthcare and fitness. Physical and occupational therapists must be well acquainted with the muscular system to plan and carry out rehabilitation programs. Athletes and trainers, dancers and acrobats, and amateur fitness enthusiasts follow programs of resistance training to strengthen individual muscle groups through movement regimens based on knowledge of muscle, bone, and joint anatomy. Nurses employ their knowledge of the muscular system to give intramuscular injections correctly and safely, and to safely and effectively move patients who are physically incapacitated. Gerontological nurses are keenly aware of how deeply a person's muscular condition affects quality of life in old age. The muscular system is so highly important to the biomedical disciplines, even beyond the scope of the movement sciences. For example, it is a primary source of body heat in the moving individual, and loss of muscle mass can be a contributing fact in diabetes mellitus. The muscular system is closely related to what we have covered in the preceding chapters. After this, we will examine the mechanisms of muscle contraction at the cellular and molecular levels. In Chapter 11 and Chapter 12, we'll shed light on the relationship of the muscles to the nerves that control them. The word muscle means little mouse, and apparently was coined by one of the ancient Greek authorities who thought that skeletal muscles rippling under the skin resembled scurrying mice. As we saw in Chapter 5, however, there are three kinds of muscle: skeletal, cardiac, and smooth. Despite their differences, all muscle is specialized for one fundamental purpose: to convert the chemical energy of ATP into mechanical energy of motion. Muscle cells exert force on other organs and tissues, either to produce desirable movements or to prevent undesirable ones. Collectively, the three types of muscle serve the following functions. Sorry, I had to yawn. Movement. Muscles enable us to move from place to place and to move individual body parts. They move body contents in the course of breathing, blood circulation, feeding and digestion, defecation, urination, and childbirth. They serve various roles in communication, speech, writing, facial expressions, and other body language. Stability. Muscles maintain posture by preventing unwanted movements. Some are called anti-gravity muscles because at least part of the time they resist the pull of gravity and prevent us from falling or slumping over. Many muscles also stabilize the joints by maintaining tension on tendons and bones. Control of body openings and passages. Muscles encircling the mouth not only serve for speech but also for food intake. Sorry, this book is making me sleepy. and retention of food while chewing. In the eyelid and pupil, they regulate the admission of light into the eye. Internal muscular rings control the movement of food, bile, blood, and other materials within the body. Muscles encircling their urethra and anus control the elimination of waste. Some of these muscles are called sphincters, but not all. This is clarified later. Heat production, thermogenesis. The skeletal muscles produce 20 to 30% of the body's heat at rest and up to 85% during exercise. This body heat is vital to the functioning of enzymes and therefore to all metabolism. When it's lacking, people die of hypothermia. Hormone secretion. Exercise muscles secrete hormones, myokines, that stimulate glucose synthesis by the liver and breakdown of visceral body cavity fat. Glycemic control. This means the regulation of blood glucose concentration within its normal range. The skeletal muscles absorb, store, and use a large share of one's glucose and play a highly significant role in stabilizing its blood concentration. In old age, in obesity, and when muscles become deconditioned and weakened, people suffer an increased risk of type 2 diabetes mellitus because of the decline in this glucose buffering function. The rest of this chapter concerns only the skeletal muscles. The term muscular system refers not only to these, not to the other two types of muscle. The study of skeletal muscles is called myology. There are about 600 muscles in the human muscular system, but fortunately, you weren't expected to learn 600 names. Many have repetitious names, such as the right and left muscles of the same name and muscle series between ribs and vertebrae. This chapter describes fewer than 1/3 of the muscles. Smooth and cardiac muscles are discussed in chapters 11 and 19. Muscle connective tissues, fascicles, and compartments. The skeletal muscle consists of much more than muscular tissue. It also includes connective tissue, nerves, and blood vessels. The connective tissue components from the smallest to largest and from deep to superficial are as follows. Endomysium. This is the thin sleeve of loose connective tissue that surrounds each muscle fiber. It creates room for blood capillaries and nerve fibers to reach every muscle fiber, ensuring that no muscle cell is without stimulation and nourishment. The endomysium also provides the extracellular chemical environment for the muscle fiber and its associated nerve ending. Excitation of a muscle fiber is based on the exchange of calcium, sodium, and potassium ions between the endomysial tissue fluid and the nerve or muscle fibers. I'm going to go off of the book for a minute. What this means is that acetylcholine basically binds to something called sodium gates, and it opens them up. So sodium flows into the cell and kicks potassium out, which polarizes the cell and leads to a positive 30 charge. And then whenever the process starts again, or is stopping, potassium comes back into the cell and depolarizes back to a negative 90. So sodium goes in first, kicks potassium out for positive 30, then depolarization happens, potassium comes back in, kicks sodium out for a negative 90. Sorry, I just decided I'd put that in there if you didn't know what it meant whenever it said polarization. Sorry, I am tired. Paramecium. This is a thicker connective tissue sheath that wraps muscle fibers together in bundles called fascicles. A fascicle typically comprises of 20 to 60 muscle fibers. Fascicles are visible to the naked eye as parallel strands, the grain in a cut of meat. If you pull apart fork tender roast beef, it separates along these fascicles. The paramecium carries the larger nerves and blood vessels as well as the stretch receptors called the muscle spindles. epi, epi, I'm very tired. Epimesium. Epime, mm, epimesium. Epimesium. There we go. Sorry, guys. I promise I'm not crazy. This is a fibrous sheath that surrounds the entire muscle. On its outer surface, the epimesium, there we go, grades into the fascia, and its inner surface issues projections between the fascicles to form the perimesium. Fascia. This is a sheet of connective tissue that separates neighboring muscles or muscle groups from each other and from the subcutaneous tissue. Muscles are grouped in compartments separated from each other by fascia. The fascicles are defined by the perimesium are oriented in a variety of ways that determine the strength of a muscle and the direction in which it pulls. According to the fascicle orientation, muscles are classified as shown in figure 10, which is basically just showing you like fusiform, parallel, triangular, unipinnate, bipinnate, multipinnate, and circular muscles. Because of the fascicles, which are the grains, you can see like which way they're going. Fusiform muscles are thick in the middle with fascicles converging on each shapered end. The biceps brachii of the arm and gastrocnemius of the calf are examples of this type. Muscle strength is proportional to the diameter of a muscle at its thickest point, and fusiform muscles are relatively strong. Parallel muscles have a fairly uniform width and parallel fascicles. Some of these muscles are elongated straps, such as the rectus abdominis of the abdomen, the sartorius of the thigh, and the zygomaticus major of the face. Others are more squarish and are called the quadrilateral four-sided muscles, such as the masseter of the jaw. Parallel muscles can span a long distances, such as from the hip to the knee, and they shorten more than other muscle types. However, having fewer muscle fibers than a fusiform muscle of the same mass, they produce less force. And I'm probably going to cut it right there because people in my house are being loud. So, if you like this, I can go ahead and continue on with this. I need to read it anyway, so it doesn't bother me at all to record it. But yeah, thank you for watching. Bye.